Okay, ladies, gentlemen, I want to give you a new coordinate system.
Ooh.
Because, you weren't bored with this one, right? So, you all remember the standard, usual coordinate system?
Yeah.
This
X
thing?
and Y. You're gonna break it now, right?
These are like X and Y, maybe? Right? And if I want to describe a point like over here, I would call that thing
X and Y.
X and Y, right? Okay. Maybe let's draw the Y on that. So what do you guys think when you see this? You all think,
Input, output.
oh, good. Okay, cool. So you might think about this as the input and output for a function. If I didn't have an associated function, so I'm just talking about points, how do you guys think about getting to a point x, y?
That's awesome. You go over and
Over, so we're going to think, all right, I went over x units, right? And then I, from there, went up y units. Yes? This is your guys' usual, I think. All right, so here's a new thing. New thing, new color. I'm going to, instead of going over and up, I'm going to go around to an angle. And then what? And then out a distance. I'm going to call that r and theta. Okay? This is the idea of polar. So instead of, right, this was over and then up, right? And instead I'm going to think about the exact same point, right, in a different way as a distance out and a theta around.
cool.
You guys cool with this?
Yeah.
Okay, let's get some unit conversions. So I think we can get easily some conversions here. So here's my old stuff, x and y, right? How do I write x and y in terms of my new pink stuff? X is r cosine.
Stuff.
You guys see that? You want to see my thought process on that?
Sure.
Okay, so my thought process is there's this triangle, right? It's got an angle theta down here. The hypotenuse is r long. It's x on the bottom and y on the vertical. Okay, so x is playing the role of the adjacent side, right? So the cosine of theta is going to be x over r. So x then is, what are you going to do to both sides here? Multiply by r, so you're going to get x is r cosine theta. Is all playing along with that?
Yeah.
Okay, so my x in my old coordinate system, right, is r times cosine of theta,
Next would be r sine of.
and y is r sine of theta. Good. For y.
Yes.
Why? Why is it r sine theta? Good, because sine is the opposite side over the hypotenuse. And if I go back to my triangle, right, the opposite side is y, hypotenuse is r, so do the same thing. Cool? Check. All right, now let's see if we can get the other way. So I should be able to write equations for r and theta in terms of the old stuff. Yeah, I should, right? Okay. What tool do you have that takes sides like the black ones and turns them into this r? The Pythagorean theorem for that, right? So r is going to be what?
X squared plus y squared.
Close. X squared plus y squared.
Square root.
And then make sure you take the square root of that business.
Does it have to be positive?
Okay, so that's a good question. Positives and negatives are a little subtle here. If I went up by an angle theta and then told you to go negative somewhere, how would you do that? Like if I said, okay, go to pi over 4, which is about what this looks like, right? And then go out 2 units. I could go to pi over 4 and go out 2 units. What the heck would I mean if I said, go up pi over 4 and then go back 2 units?
Third quadrant.
Yeah, you'd be looking down here, right? You guys all see that? So I'm going to assume that R is positive when I give you a standard graph, right? Of course, R is going to be allowed to be negative. You'll just go backwards. You guys see that? But for standard reference, R is going to be positive. So when you guys are making these, make R positive. You guys see how to do that? I just need to change the angle, right? Okay. How about theta? What was your thought? Tangent, right? Okay, hang on. I'm going to need to think for a second. Why am I going to need to think for a second? What's tangent? Tangent of what? What are you going to apply tangent to? Okay, you got to apply tangent to an angle, right? Okay, so I'm going to say tangent of theta. All right, what's tangent of theta? Opposite over the adjacent, so that's y over x. Good. Okay, so how the heck do I get theta out of this thing? Because that's really what I wanted, right?
Inverse tangent.
Oh, I need to untangent both sides.